So planning experiments 2016 session papers. You will find a common experiment which is normally about the rate of cooling. That experiment is the most common one. You will find repetition is there with different factors which we are investigating. So from March 16 paper, a student suggested that the area of water surface will affect the rate of a cooling of hot water. This is a suggestion by the student. So we have to plan experiment to investigate the relation between the surface area and the rate of cooling, like how the surface area can affect the rate of cooling. Write a plan of experiment including the apparatus needed. So what apparatus we need when we are investigating the rate of the cooling? So we need, because we are investigating how the rate of a cooling is affected by different surface area. So we need containers or beakers with different size. And to know how much the temperature change, so we need a thermometer. And whenever something is refers to a rate, we always have to measure a time. So what else we need? We need an stopwatch. So the apparatus which we need here, we need containers of different size. Or surface area. We need a thermometer. And we need a stopwatch because we are investigating how much time the reaction mixture or a mixture will take or a hot water will take to cool down. So these are the things which we need for investigating the rate of a cooling. How you will obtain a so how you will obtain a range of surface area, like how we'll get or different surface areas. So basically we'll change the container, we will change the size, we'll take different types of containers. By changing the container, the surface area will change. So how you will obtain a range of surface areas? So we will take containers, or by changing the container. So when we change the container, the surface area will change. And we can repeat for 5 different types of containers. Instruction for carrying out the experiment. So how we plan whenever a rate of cooling experiment is there. So what is the procedure? We will take hot water inside a container, record its initial temperature, by thermometer. Then we will start the timer, the stopwatch, and record temperature for every 30 seconds for 3 minutes. You can carry out for 5 minutes or 3 minutes, and then we will repeat the experiment with 5 different types of container. So this is the same procedure as we already discussed, similar type of questions, similar type of experiments. So that's how we carry out this experiment. The measurement we will take. So what measurements we are taking? We are recording the temperature and we are measuring a time interval. The precaution you will take to ensure that the results are reliable. So what precaution we should take? That the results are valid results or reliable results are there. So every time when we are doing the experiment, we should keep the room temperature or the lab temperature same, or we should take hot water at a same initial temperature. Because like if we take two different or three different containers and the hot water is at different temperature, so it won't be a fair comparison to identify that which one cool down faster. So for precaution which we'll take that the results are reliable. So the initial temperature, the lab temperature, temperature of the initial temperature of the water should be same. The type of the container should also be same, because like example, if you are taking all the copper container, then it will be suitable. Otherwise, if you take one container made up of a glass, another one copper, another one aluminum, then it won't be a fair comparison, because we are only investigating how the surface area can affect the rate of cooling. The graph you will plot from your result, you should sketch an axis with appropriate label. So you should sketch an axis means like what you will have. So look, two quantities which we are measuring a temperature and we are measuring time. So time will be there on x-axis and temperature in degrees centigrade should be there on y-axis. We don't have to sketch any line here. We just have to sketch the axis which will take, like on y-axis we'll take temperature, on x-axis we'll take the time. But you don't have to sketch the result here as you don't have any values. So this was the experiment from Feb-March session. Then summer 16. Again, as I mentioned, you will find very frequent questions related to rate of cooling. So a student is when investigating the effect of insulation on the rate of cooling, like how the insulation means the material which does not allow the heat energy to pass, we call insulator. So how the insulation can affect the rate of cooling of a hot water in 250 cm cube container. The student can choose from the following apparatus. He can have a glass beaker, plastic beaker, copper can, a measuring cylinder, three different insulating materials are there, a clamp boss and stand, this is all one part, and a stopwatch. We have to plan an experiment to investigate the effectiveness of a three insulating material, like which is a more effective insulating material or which material is more effective in reducing the heat loss to the surrounding. So first part is explain briefly how you would carry out the investigation. So how we will plan this experiment or how we carry out the experiment. Remember, because we are investigating the thickness, how the insulation can affect the rate of cooling. So we should take the same container for all the three apparatus, like all the three parts, as we have three different types of insulating material. So we will pour hot water, and you can take any one of them, like pour hot water into 250 cm cube copper container. Any one you have to take, because you cannot change the container. Otherwise, if you change the container, then the experiment won't be fair comparison, as the type of a container can also affect the rate of cooling. So we just want to investigate, like if we have a container, a 250 cm cube container, and we place an insulation around it, or insulating material is placed around it, how the rate of a cooling can be affected by this insulating material. So pour hot water into a 250 cm cube of copper container, then record its initial temperature. Then start the timer, record temperature every 30 seconds for 3 minutes. Then we can repeat the experiment. And I should, because we are finding the effect of, which is the most effective insulation, effectiveness of insulation. So we'll take a copper container and place insulating layer 1. And we'll record the initial temperature, start the timer, record the temperature for every 30 seconds for 3 minutes, and then we'll repeat experiment with 2 other insulators or insulations. This was a procedure. And when you're writing the experiment, try to write the experiment. Avoid writing a paragraph. The reason why I say avoid writing a paragraph, because when you're writing a paragraph, you may miss any point. So it's better whenever you're writing the experiment, try to write the experiment according to the points which they mention. Like, try to answer this first point, how you carry out the investigation. Once you're done with the first point, you will move on to the second point instead of writing the whole paragraph. So what are the key variables we should keep constant? The lab temperature. Yeah, that's good. Initial temperature, volume of a water, same type of a container, same room temperature, thickness of insulating material, and the time interval. That's good. So these are the factors which we should keep constant for a fair comparison. Then draw table or tables with a column heading. So what are the tables? We'll have a time, and you can draw, like, you can have all on the same table, or you can draw separate table. Like, time interval is there, then temperature with insulation 1, or insulation A, insulation B, and insulation C. You don't have to fill the table, but table will always with a column heading. So we have this time is there in second, temperature is there in degree centigrade, temperature in degree centigrade, temperature in degree. So insulation A, insulation B, and insulation C. Time we can mention here as like 0, 30, 60, 90 till 180 as 3 minutes are there. But temperature you cannot write any value as you are not doing the experiment. Then explain how would you use your reading to reach a conclusion. So we will plot a graph. On x-axis, we'll have a time. On y-axis, we have a temperature, and rate of cooling is actually the gradient or the slope. So we'll plot temperature on y-axis and time on x-axis, and the slope of this graph is representing a rate of cooling. The one which is having a steeper slope, it means that cool down faster, so that is not an effective insulation. The one which is less steeper, it takes longer time to cool down, so it means that is an effective insulation. So the rate of the cooling can be investigated by plotting a graph between temperature and time, and the one which is steeper means that cool down faster. The one which is less steeper, it means it slowly cool down. So slope represents the rate of a cooling. So C is having a smaller rate of a cooling. So that is the effective insulation. Again, you don't have to sketch A, B, C. I'm just explaining that if the graph was there, then how to identify the rate of a cooling. That you will check the initial slope. The one which is steeper means that cool down faster, and the one which is less steeper, that will take longer time to cool down. So again, a similar, as I mentioned, the rate of a cooling is a very common experiments you will find in different past papers, and repetition is also there. Only thing which might change is the factor which we are investigating. Sometimes we investigate how the thickness of insulation can affect. Sometimes we investigate how the surface area is affecting the rate of cooling. Sometimes we investigate how the type of a container affects the rate of cooling. Sometimes we can also investigate how the surrounding temperature can affect the rate of cooling. Then Experiment from winter 16. A student investigating resistors connected in parallel. The following apparatus is available: ammeter, voltmeter, a power supply, a variable resistor, switch, connecting leads, and a box of identical resistor. Plan an experiment to investigate how the combined resistance of resistor connected in parallel depends on the number of the resistors. Like if we change the number of resistor, how the resistance can be affected. Practically, when we connect more resistors in parallel, the combined resistance will decrease. But we don't have to reach a conclusion or a result here. We just have to plan this investigation, that how we carry out. So draw a diagram of the circuit that could be used to determine the resistance of resistors connected in parallel. So only two resistors in the diagram. So we will have two resistors which are connected in parallel. How to, in a circuit, how we can find the resistance of a circuit? So for that, we use a voltmeter. The voltmeter is always connected in parallel to measure the voltage. And we use an ammeter, which measures the current. Then we have a power supply. So this is a symbol for power supply. Then there's a switch and a variable resistor. So we can change the voltage and current to find the different results. So this is a circuit which we'll use to investigate how the number of resistors can affect the rate of, how the number of resistors can affect the resistance of a circuit. Briefly, how would you carry out the investigation? So how we plan this experiment or how we carry out this investigation? So we'll connect the circuit as shown. Then we'll connect a voltmeter to measure the voltage and ammeter to measure the current. And then we will repeat the experiment by adding different number of resistors. Like first we start with two resistors in parallel. Then we'll add another resistor, three resistors in parallel, and four resistors in parallel, and so on. So how we carry out this investigation, we'll connect the circuit. And we'll connect the circuit with two resistors in parallel. Then when two resistors are connected in parallel, we'll measure the voltage by voltmeter. And current by ammeter. Then we'll find the resistance of the circuit. That R resistance is actually a ratio between voltage and current. So we'll get the resistance of a circuit. Then we'll repeat the experiment by adding another resistor and repeat the procedure till, for example, 5 resistors in parallel. So this is how we carry out this investigation. Draw a table or tables with a column heading to show how you display your readings. So how we represent a table or table. So we'll have number of resistors. The first one column will be a number of resistors. The second one will be the voltage. The third one is the current, and the fourth one is the resistance. We don't have to write any number value. We just have to complete. A table must be with a column heading, means the unit should be correct. So this will be a number of resistors. Number of resistor does not have any unit because it is a number. So it will be 2. It cannot be 1 because you are finding combined resistance. So 1 does not have any combined resistance. So 1 cannot be written. 2, 3, 4, and 5. Then we'll have a voltage, which is volts. Current is there, denoted by I, ampere. And then the resistance is there, which is ohm. So voltage is there, current is there, and resistance. When we divide all voltage with the current, we'll get the resistance. You don't have to write any number here. So this is how we represent our result.